was shared that a problem that you guys should be able to do when we're getting started is one like this. And it's kind of along the lines of what we're talking about. So I thought we'd just work through it. So this was presented as a problem that you guys should be able to do. And I think you all can, but it's scary when you look at it. Now when we say, let's focus right here for a minute. When we say g of 4 is 8, what does the 4 represent in terms of the equation? That's the x. And what does this represent?
The answer.
The answer. So, like, we could think of this as y, and that would be 8, right? So we could take this point, this is essentially an ordered pair, 4, 8, and we could plug it into the equation. So 8 equals a times 4 squared plus 24. Agreed?
Agreed.
And we can then figure out what the a is. Well, that worked out nicely, didn't it? So our equation, our function, is really negative x squared plus 24. So when I'm asked for this, all I need to do is what? Plug it in. So g of 3 would be negative 9 plus 24, which is what, 15? So, you okay with that? I just thought it was interesting. They raised that today at our department meeting, and I thought, oh, my kids ought to be able to do that. And we're talking about functions right now. What we're going to talk about today in terms of functions is very simple. Let's say we have 2 of them, 2 functions. We're going to talk about adding them, subtracting them, multiplying them, and dividing them.
It's pretty easy.
And building a composition of them. You have done all of these things. What would f plus g be? Do not make this hard, this is so easy. F plus g would be what? X squared plus x plus 4. I'll put it in descending order. F plus g just means add them. How about f minus g? X plus 4 minus x squared. Vincent? You got it?
Yeah.
Okay. You know when they are doing football games on the radio, they call you Vinny?
Oh, really?
Yeah. Okay, f times g, that would just be x squared times x plus 4, or x cubed plus 4x squared. There, it doesn't get harder than this. Is everybody okay? This is easy. F divided by g, x plus 4 over x squared. Now that one, there is a little bit of, I don't know how to say it. There's a little something you have to be cognizant of. What's the domain of function f? All real numbers. Let's say this again. What hinders domain? Denominators and radicals. Does that function have a denominator or a radical? So its domain is going to be all real numbers. Unless it's something weird like a logarithm or something, it's going to be all real numbers. What's the domain of this one? All real numbers, right? The domain of this, all real numbers. But now we got to stop a minute. The domain of this is not all real numbers, is it? Because now we have a fraction, denominator. So this domain would be everything except 0. So you have to be careful when you're building these quotients that you remember that's going to restrict your domain. composition. Does anybody remember how we say this? And by the way, you may have seen it like this with a little open circle there. It's the same thing. Different notations for the same thing. Anybody remember how to say it?
F
Not fog.
of G of X.
I mean, you can think fog, but don't say fog. F of G of X, exactly. This notation is F of G of X. That's how we say it. And again, that little open circle there can represent the same thing. Those are two notations for the same thing. F of G of X. Now, F of G of X. What is G of X? X squared, right? So isn't F of G of X just saying find F of X squared?
Yeah.
And how do we find F of anything? We take out the X and plug in whatever it is we want to plug in. So that would be X squared plus 4. What about G of F of X? G of F of X. I like this notation better because it clearly says I want G of F of X. Well, what's F of X? X plus 4. So I want G of X plus 4, which means I take out the X and put in X plus 4. That would be X plus 4 squared. You try one. A lot of you are just staring at me blankly. Let's say H of X is 2x minus 3, and P of X is 3x. And we're going to find H of P of X. Right now on your paper, do that for me. See if you can come up with H of P of X. Remember, P of X is 3x. So you're finding H of 3x. And then when you're done with that, if you're comfortable that you got the same answer I did, let's find P of H of X and see if we get the same answer.
Thank you.
Anybody have any questions about that? Did you get the answers I got? Notice they're not the same, right? So order matters. This is not a commutative operation. Order matters. Gotta do it in the right order. Okay? Tonight, you're just going to be doing that kind of stuff, so I don't think I need to talk about it anymore. Let's look at last night's homework, though, because that had some harder stuff in it. Okay, we've got, we need to go over your tests. We will, if we don't get that done Friday, we'll do that next week, because next week we have some longer periods. The schedule's kind of different next week, so. All right, so who had a question about a homework problem? Give us a question. Let's take care of it. Hannah,
45B, I mean 40, 54B, sorry.
54. I need to do A first.
Just like,
Yeah.
All right, so let's see what's going on here.
Sorry, did you
So I'm graphing 54 on my calculator, so I'm going to put it in this equation. And let's see, I want to put a standard window in there. Oh, wow. It says, which function does it appear to be? It appears to be the absolute value. But there's something freaky going on near the origin. So I'm going to adjust my window a little bit. Whoops. See what's going on. Yeah, it's not the absolute value function. There's something different happening there. And it tells me to do this algebraically to prove it.
No, this is numerically. So the same thing as a
All right. All right, so let's see if we can prove this algebraically. I shrunk my window down and I was looking at some small values of x. So let's pick, okay, we're comparing it to the absolute value function. We think it's very much like the absolute value function. So let's just put some numbers in. So if I put in 1, I get 1. What do I get over here if I put in 1? I shouldn't get 1. I hope I don't get 1. Let's see what I get if I put in 1. Just stick it straight into the function. So that would be 1 plus 0.0001 minus 0.01. Okay, I got 0.99. So if this were the absolute value function, I would have gotten 1. I didn't, so it's not the absolute value function, even though it looks like it is. Now, how did I know? I don't know what would have happened if I would have picked a bigger number. But I picked a small number because it looked like when I did the graph that the difference, there was something weird happening at the origin, so I just picked a small number. Okay? Interesting. All right, who else? Jamie? 33. Use your graphing calculator and determine the domain and range by looking at the graph. Okay, I gotta remember. Okay, all right, so I want to graph this equation, so I'm going to go back, I'm going to readjust my window and use standard window again. I just messed it up. And I'm going to put in this equation into my calculator. So to get the greatest integer function, go into your math menu and click over to number. Remember, that's where we got absolute value from. and the greatest integer function is down in that list. So you just find that, hit that, and then type in x divided by 2, and hit graph. Now, the thing about this is, it connects, at least mine. Maybe the newer calculators don't do that, but mine, is yours just actual bars? Okay, see, mine connects like a staircase. Oh, you guys, this is much better than mine. I have an older calculator. So you can see the steps, right? So what are we supposed to do? Find the domain and range. Okay, now, do you have a standard window set? Then you should be able to tell how wide those bars are. Can you tell? Too wide? All right. And then, can you tell how far apart they are, like vertically? 1. Okay, so what is your, so that means you have a bar where y is 1, you have a bar where y is 2, 3, and so on. So what's your range? All integers, right? You got a bar. Every integer you have a bar. What's your domain? All real numbers. Yeah, you covered them all.
The range is all real integers.
The integer, or the range is just integers. Yeah, it's a set of integers. Because it's not all real numbers because you don't have a half and a third and all that. You have every integer covered.
Oh, it is that. It has an open circle on it.
Because that's filled in at the next one above. All the x's are used. So whatever, so on this bar, maybe the 2 isn't used here, but it is used here. So every x value is covered. Not every y value is covered, just the integers are covered.
So it's not all real range?
No, because you haven't graphed these y values. The only y values, if you looked at all the ordered pairs, the y values would just be things like -1, -2, 2. These are the y values that you've plotted. Just the integer values.
So I have to list all the numbers?
No, you just say the set of integers. Your range is the set of integers. Yeah. If you tried to list them all, Jamie, you'd be my age and still doing it, right? Yeah, just the set of integers.
Where is that on the calculator? I know it's under math.
If you go to math,
Yeah.
click over to number,
Okay.
it's down the list. For me, it's number 5, but I have an older calculator,
yeah,
so I
okay.
don't know.
Yeah.
Is it gonna be integers for like all the greatest integer functions?
Well, you have to be careful because, like this equation, what did putting the 1/2 x over 2? What change did that make in the graph? It made the steps 2 units longer. Could we put an adjustment into the graph that would make these steps maybe 2 units instead of 1? We absolutely could. So it will be either the set of integers or a subset of integers. Okay? If we increase this to 2 steps, then it would just be even integers. You see what I'm saying?
Yeah.
Yeah.
51.
Which one?
51.
51. Now they ask you specifically, let's try this without a calculator. I think it's easier without a calculator, actually. And we are graphing x squared, absolute value, and the greatest integer. X is less than -1, between -1 and 1, and bigger than, oops.
I could have 51.
Oh, wait, 51, thank you. Okay, do I have it right now? Okay, all right, so let's just, a piece at a time. Let's graph the line, -3 minus x. All right, so this is a line. It's kind of backwards, but it's a line with a slope of -1, and a y-intercept of -3. So I can graph that. So y-intercept of -3 and a slope of -1. So that's up 1, left 1, up 1, left 1. Okay, so that's going to look like this. Would you agree with that? That's the line?
Yeah.
But I don't want the whole line. I only want the part of the line that's less than or equal to 0. And that's right here, right? So I want x to be less than 0. So won't that be the left side?
Yeah.
So I'm going to get rid of this. And because that's an or equal to, I'm going to leave that nice solid dot right there. And that's a picture of the top line. Now, in between 0 and 1, so just this little section right here. Here's where x is 0, here's where x is 1. So in between my hands, what are the y values? 1. This says y equals 1. Y equals 1. So all between my hands, all the y values are 1. Well, doesn't that happen right here, kids?
Yeah.
So between my hands, I have to have a y value of 1. And those are open dots because between my hands aren't included. The 0 and the 1 aren't included. So I have a little step right there. And then I have my good friend, the parabola, right? And I can go ahead and draw in my parabola. Just to get a good shape here, I'm going to plot a few points just to make sure. So here's my whole parabola. That's this curve, x squared. What part of that do I want? Where x is bigger than 1, here's where x is 1. So bigger than 1 would be this part, which means I don't want this part. And because that's an or equal to, that dot has to be colored in, right? So there it is. Emma, you okay with that?
Yeah.
What is the domain of this function? All reals. Right here's your domain, kids. Doesn't that cover everything? What is the range of that picture? Be careful. Victoria? Greater than or equal to -3?
Yes.
Yep, that's exactly right. Your range is greater than or equal to -3. Very good. Lily?
On number 36, it was like I think the question was, the graph was a sine one, and it asked for A if it increased or decreased, but because it goes up and down, I didn't know.
Yeah.
It just both.
Yeah, it has infinitely many increasing and decreasing intervals. That's about all you can say.
Okay.
You're exactly right. What happened to number 36? When you take the sine and add 5 to it, what happens to it? It goes up 5. So the original sign was oscillating between 1 and -1. If you picked it up 5, so your range here was between -1 and 1, right? What about the +5 one? What would your range be then? 4 to 6. Yep, very good. Very good. Yeah, when it comes to sine and cosine, they have infinitely many increasing and decreasing intervals, so you can't really be any more specific than that.
For number 30, I was confused. Do you go down 4?
For number 30,
Yeah.
let's talk about that. Because that's an important distinction. We know we're going to shift. Anytime you take a function and add or subtract, you're going to move it. Up, down, left, right, you're going to move it somehow. We have to distinguish that equation from this one, kids. They both move, but what's the difference? This one moves down 4. Whenever you deal directly with the x. When the change, the add or subtract is with the x. Not tacked on the end, but with the x, it's horizontal. And the thing about horizontal things is what? They're opposite of what you would think. So if it says -4, you're actually going right for it. And I want you to think about, I forget who asked about it, but that greatest integer one that we graphed on our calculator, it was x divided by 2, but what did it actually do to the steps? It made them twice as long, didn't it? Anytime you operate on x, it's opposite of what you think. So if you think you're dividing by 2, oh no, you're really multiplying by 2. If you think you're subtracting 4, oh no, you're really adding 4. Yeah. All right, anyone else? Yeah, Jasmine.
Number 16.
By the way, good game last night, all volleyball players, okay? We just decimated them, it was wonderful. It was Shatar, and it was just so wonderful. They were like, it was so good. Which one? Number 60. Did you say 60? 60? Okay, which function has a range of all real numbers? Yeah? All right, anybody else have a question about, you know what, let's talk about 60. Which function has a range of all real numbers? Because this requires you kids to really know your basic functions. Now the question is, the range is all real numbers. Let's talk about this one first. We just talked about this. Is the range of a cosine all real numbers? No, it has a very small range, relatively speaking. Greatest integer. Okay, we just spent some time talking about that. What's the range of a greatest integer function? It's going to be the set of integers, not the set of all real numbers. It's going to be the set of integers, so that's not it. Now, what kind of function is this?
Exponential.
No, not exponential. It's 5 over, it's something over.
Reciprocal.
That's a logistic function. Okay? This is a logistic function. And what does now it's not the basic logistic, there's a different number there. But what is the general shape of a logistic function?
Doesn't go over one.
It has an asymptote at the bottom and an asymptote at the top, and it's trapped in between. So would the range of this ever be all real numbers? No. This is a tricky one. This is a version of the reciprocal function, right? Now, I want you just to think about the reciprocal function. Does it have a range of all real numbers? Be very, very careful. Doesn't it have an asymptote here?
Yeah.
So y can't be 0. Now, when you stick in a 3, you're going to move it around and flip it over, but there's still going to be a number it can't be, right? So the answer is right there. That one has a range of all real numbers. All right, have a good day. Remember, you have until the end of the day to get me your math week stuff if you haven't already. Not messing around with that. You're going to want to record it.
Well,